Yeah, so hi everyone. Today we are going to solve this problem of the day for today, which is 12 December. Let's see what is the problem. Okay. So transpose of a matrix. So let's see. Okay, you are given a square matrix of size n cross n. Your task is to find the transpose of the matrix. The transpose of the matrix is obtained by converting all the rows to column and the column to rows. Okay, let's take one example. Okay, so n could be up to 10 to the 3. So our problem should be more than in log n, I believe. Yeah. Now n could be up 10 to the 3, so n square could be 10 to the 6. So yeah, we can at most iterate one element on log n time, I believe. Yeah. See. So in this example, what they are given, they have given one, one. This is the first row. This is the second. This is the third row. This is the fourth row. But after transforming it or by performing transpose operation, what they got this row here, the second row is over here, this 2 2 2 2, this one is here, this 3 3 3 3, this one is right here, this one is right here, so 1 2 is here, 9 minus 2 is here. Okay, so let's take another example. So see there it looks. So let's say that array looks like 1 5 9 2 6 4 8 1 2. So after performing the operation, the transpose matrix of this particular array would look something. 159 will come over here, 264 will come 6 and 812. So let's see how the transformation is working. So this is the zero, this is the zeroth row, this is the first row, this is the second row, and column wise this is the zeroth column, this is first column, this is second column. Same for this one as well, but the change that we got uh, from the first array to the second array, that is the zeroth zero zero element is same. Let's say this is A, this is B. So A of 0 0 is same as B of 0 0. But A of 1 0 was transferred to A of 0 and 1. Similarly, let's say for 4, A of, so 4 was at 1 comma 2 index, which was transferred to 2 comma 1 index. Okay, this will be B. Okay. Index. So we can see that basically the index got changed. Uh, so for any ij, the position of the element which was at ith row and the jth column would be in the second array of jth row and the ith column. So that's how we are going to get the transpose matrix. So there are a couple of ways by which we can get this transpose matrix. One is by simply creating another array uh, of size in percent and then returning the newly created array. But that would be, the space complexity would be what big of, as we are going to create a new array of size in process. So the space complexity would be big of n square and the time complexity would be also big of n square. Since there is no way we can get more optimized solution in terms of time complexity, so let's see if we can get any solution that can have less space complexity by using the already existing array, the array that we have. So, but there is a problem. So whenever we are going to, so no, the first question that should come to our mind is that if we swap the I and j, the element with the j and I element, let's see what do I mean by that. So suppose there is 3 by 3 matrix. And suppose we want to iterate over all the row and iterate over all the column and then swap each of the element one by one. Then what are we going to have? See, so this is the same array, but suppose we say that okay, we are going to iterate for each row and then for each column, and let's say that we are going to say that okay, array of ij should be array of ji. So for 0 0 it is going to do nothing, so it will start from 0. So the value of I would be 0 and the value of j should be 0 at first, so it should not change anything. But when the value of I would be 0 and the value of j would be 1, then it will say that okay, array of 0 comma 1 should be array of 1 comma 0. So array of 0 comma 1, which is at this point, it should get the value from the 1 comma 0 index, that is this index. So 2 will come over here and 2. So after just one operation or after just two operations, the array would look something like this. But the problem is that we lost the element that was supposed to be at this index. So that's an is no, actually we didn't lost the element. If we do swapping, then basically we are going to swap the element. So that means we will go over there and 7 will come over. Uh, so actually we can do this. If we do swapping, then but we need to make sure that we are not swapping two times. So I and j should be unique. So once we do this for 0 and 1, we should not perform this again for 1 and 0. So to do that, for performing operation on unique img, unique img, what should we do? We should start our loop from 0 to n. Is wrong. We should start our j from I plus 1. We can start from I, but that doesn't make sense. Plus 1. That's how we are going to do that. Yeah. Should give us the solution that we want. Let's check. Okay, this is gone. This is great. It's the one that. So let's first calculate the value of n, which is the number of rows that the matrix has. Since the number of rows and columns are same, so we don't need to count the number of columns that it has. So the number of rows is fine. Now we don't need to create another array, we just need to loop over all the rows, and we need unique img. We don't want to repeat that, so that's why we are going to start our j from I plus 1 and j should be less than 1. Till then we should increase j by 1, and in each step we are going to perform the swap operation. But there is a problem. We got so let's see. Amount of ij and amount of ji. Then we are going to return this particular array without using any extra space. I believe that should solve the problem. Is it? It is working. Okay, looks like this ampersand doesn't the code. So okay, that's why it is working. So thank you so much guys for watching this video, and let's see if I continue doing more such tutorial. Stay tuned for that. Bye.